Welcome to the Deep Dive, your shortcut to really getting a handle on complex ideas. When most of us think about metaphysics, those really big, deep philosophical questions about reality, what exists, what causes things, time itself, we tend to picture philosophers working in a specific way.
Right, you imagine pure deduction, logic, arguments starting from first principles, building these grand systems of thought, all completely independent of experience, a priori knowledge.
Exactly. That's the classic picture, towers of reason built just on logic.
And historically, that's often how it was presented and how many understood the goal.
But today, we're diving into a way of thinking that says, hang on, that's not the whole story. It argues that if you really want answers to the biggest questions, you can't just ignore how science works. You actually need induction. We're talking about inductive metaphysics, or IM for short.
That's right. And our goal today is, well, to unpack what inductive metaphysics really involves, and maybe more importantly, show how it isn't some radical new idea, but actually works as this kind of integrator.
An integrator. How so?
Well, it connects the dots. It links up major historical philosophical traditions, and we're going to spend a good chunk of time showing its surprising importance right in the heart of Immanuel Kant's philosophy.
Which most people think is purely deductive.
Precisely. And it links that all the way through to how we tackle problems using data and models in, contemporary science and philosophy today.
Okay, so the basic idea is inductive metaphysics uses inductive methods like scientific reasoning for metaphysical questions.
That's the core. And the most common tool it uses is something called inference to the best explanation, or IBE. Sometimes it's called abduction.
Right. So instead of starting with absolute certainties, IM looks at what? The evidence, the phenomena.
Exactly. It looks at the phenomena, successful scientific theories, observations about how reality seems to work, and then it asks what underlying principles or structures would make the best sense of all that evidence. It's an inference to the explanation.
Got it. And you mentioned historical connections.
Yeah, this approach has deep roots. It connects directly to movements like critical realism, the idea that we can know things about a mind-independent reality, even if indirectly, and also logical empiricism, which, really try to ground everything in empirical observation.
So it's about blending that philosophical quest for deep reality with the methods science uses.
That's a good way to put it, harmonizing them. But to really make that case, we have to tackle the big figure everyone assumes is induction's #1 enemy, Immanuel Kant.
Okay, let's do it.
Right. So this is where things get really interesting, I think. Because the standard story about Kant
is all about a priori knowledge. Necessary conditions for experience. Stuff we know before experience.
Exactly. His critical metaphysics, the whole project of the critique of pure reason, seems totally focused on deduction. Establishing those necessary structures, space, time, causality that have to be in place for experience to even be possible.
So yeah, where would induction fit in? Induction is messy, it's probabilistic, based on experience. Seems like the opposite of Kant.
Well, this is where inductive metaphysics really challenges the standard reading. It argues that actually inductive reasoning plays a crucial, often overlooked role within Kant's system, especially in his metaphysics of nature.
Okay, I'm intrigued. You're saying Kant used induction. How?
We can pinpoint several places. Let's start with a big methodological one, the analytic method and the experiment of pure reason.
Okay.
Even before his famous critical period, Kant was already engaging with inductive ideas. The sources show that in his 1764 prize essay, he actually argued that metaphysics should borrow Newton's analytic method from natural science.
Borrow Newton's method. That's surprising for Kant.
It is, but it shows he was deeply thinking about scientific methodology. And this analytic method, what is it? Fundamentally, it's an inductive way of working backwards.
Backwards from what?
From observed phenomena. You start with what you see, what you measure, and you trace back, you infer the governing principles or the underlying causes that must be producing those effects.
Ah, okay. Like finding the cause from the effect.
Precisely. It's the analysis part of the broader analytic synthetic method. This two-step approach goes way back. Pappus, Galileo, Descartes, Newton all used versions of it. Analysis is the inductive bit, effects to causes. Synthesis is the deductive bit, applying those inferred causes to explain other things.
So the analysis part is where the discovery happens, inductively.
Yes, and Kant explicitly connects this successful scientific way of thinking to his own philosophical project. He does this in that famous preface B to the Critique of Pure Reason, where he talks about the experiment of pure reason.
The experiment of pure reason. That's about the antinomies, isn't it? The contradictions reason falls into.
That's right. Specifically, the cosmological antinomy, where reason seems to prove both that the world must have a beginning in time and be finite in space, and that it must be infinite in both. Contradictions.
And this happens if you assume, what was it? Transcendental realism.
Yes, if you assume the world exists totally independently of how our minds structure experience. Kant shows this assumption leads reason to contradict itself. Now, the derivation of that contradiction, that's pure logic, pure deduction. If P leads the Q and not Q, then P must be false.
Okay, so that part's deductive. Where's the induction?
The induction comes in how he justifies ditching transcendental realism and adopting his own theory, transcendental idealism. He frames the whole process as an analogy to the inductive analytic synthetic method. He calls it a checkup, a Gegenprobe.
A checkup, like testing a hypothesis.
Kind of. Think about chemistry. An experiment of reduction might isolate something, then you apply a known process to see if it behaves as expected, confirming its identity or structure.
So Kant is saying, look, this assumption, transcendental realism, leads to contradictions. Let's try my assumption. Transcendental idealism, where space and time are forms of our intuition. Does the contradiction go away?
Exactly. Does the system become consistent under this new assumption? If realism fails the checkup by producing paradoxes, and idealism passes by resolving them, then idealism is inferred to be the better explanation for why reason works the way it does, and why the paradoxes arose in the first place.
Ah, I see. So while the internal logic is deductive, the reason for accepting the whole shift is based on this comparative inductive logic. It's the explanation that best resolves the problem.
Precisely. It's a consistency test, framed using the successful methods of science. What really stands out is Kant's willingness to lean on this inductive analogy, drawing credibility from Newton, to make his most radical philosophical move, transcendental idealism, seem more compelling, more grounded.
That's actually brilliant. He's basically saying to the empiricists, my weird-sounding theory actually follows the same kind of reasoning that makes your science work.
It absolutely ties his abstract philosophy to a respected empirical methodology. It shows that for Kant, the way you argue, the methodology matters immensely, even when you're talking about the fundamental conditions of knowledge itself.
Okay, that's a strong case for induction playing a role in his core argument. What else? You mentioned specific tools within reason itself.
Yes. Let's move to the regulative use of reason. These are probably the most obviously inductive tools in Kant's critical philosophy.
Regulative principles. These aren't the same as the categories, like cause and effect.
No, exactly. The categories are constitutive. They structure how we must experience things. Cause and effect applies necessarily. But the critique shows our understanding is limited. It gives us the rules, but it doesn't tell us how all the diverse empirical laws we discover actually fit together into a coherent system.
So we need something else to guide scientific discovery.
Right. The regulative principles are guidelines, not rules that constitute reality. They tell us how we should search for knowledge, how we should try to organize it to find systematic unity in nature. They are essential for guiding the inductive process of science.
What kind of guidelines are we talking about?
They function by presupposing an idea of a unified whole of knowledge before we have all the parts. Reason sort of projects this idea of unity, and that guides our search. Think of principles like homogeneity, specification, and continuity.
Okay, homogeneity. So that sounds like wanting things to be simple, unified.
Exactly. The principle of homogeneity tells us, seek unity under diversity. Don't multiply fundamental kinds of things unnecessarily. If you see lots of different phenomena, assume there might be a single underlying power or principle explaining them. It pushes us toward reduction and finding commonalities.
Like searching for a theory of everything in physics.
That's a perfect modern example of the regulative principle of homogeneity at work. It's a purely inductive drive. Assume simplicity exists and go look for it.
And specification. Is that the opposite?
In a sense, it tells us, recognize diversity within unity, even if things belong to the same broad category. Look for the specific differences and the distinct laws that govern them. Don't oversimplify.
And continuity.
Assume no huge gaps. Nature doesn't make leaps, natura non facet saltus. Look for intermediate steps, gradual transitions between forms or causes.
So these principles, homogeneity, specification, continuity, they guide scientists in making inductive inferences. How to organize data, what kind of theories to look for.
Precisely. They are the philosophical justification for the inductive impulse to find order, simplicity, and completeness in our scientific picture of the world. Without them, science would just be a heap of disconnected facts.
And this connects to his later work too, right? In the Critique of the Power of Judgment.
Yes, very much so. This general idea of seeking systematic unity gets refined, especially for biology, into the regulative principle of the purposiveness of nature.
Purposiveness, like intelligent design.
Not quite in that loaded sense. Kant is very careful. He says we cannot know if nature is actually designed with a purpose. But especially when we study complex organisms, we find it incredibly helpful, maybe even necessary, to think of them as if they were designed for a purpose.
Like assuming the heart is for pumping blood helps us understand it.
Exactly. We can't deductively prove that's its ultimate purpose, but assuming purposiveness helps us find the systematic connections between the parts and the whole organism. It guides biological research. It allows for teleological explanations in terms of ends or functions, which are super useful in biology.
But it's still just a regulative principle, a way we need to think to make progress.
Yes. It's an assumption that allows us to find systematic unity under empirical laws, but we can never claim it's an objective feature of nature itself. It's the best explanatory stance for making sense of biological complexity. It's another inductive tool.
Okay, so we have the analogy to scientific method and these regulative principles guiding inductive search. This is already more induction in Kant than I expected, but you mentioned something even more direct. Theory choice in physics.
Ah, yes. Case 3. Theory choice in rational physics as inference to the best explanation, IBE. This, for me, is maybe the most striking example.
Where does this happen?
In his Metaphysical Foundations of Natural Science, the MFNS, this is where Kant lays out his own theory of matter. He argues against the dominant atomist view.
Atomism being tiny, indivisible particles in empty space.
Right. The idea of absolutely dense passive atoms moving in a void. Kant called this the mathematical mechanical way of explaining matter. He proposed his own metaphysical dynamical MD theory instead.
His theory was based on
Forces. Fundamental, attractive, and repulsive forces. For Kant, matter wasn't fundamentally passive lumps, but centers of force. What defines matter is its activity, its forces.
Okay, two competing theories.
Yeah.
How does he argue for his... Does he deduce it from the categories?
That's what you'd expect, right?
Yeah.
But no, not entirely. He actually sets up an explicit comparison between the two theories. He weighs their pros and cons based on theoretical virtues. He performs, essentially, an inference to the best explanation.
Wow. Okay, hold on. Kant, Mr. A priori certainty, is doing a cost-benefit analysis of scientific theories based on
Right.
simplicity, explanatory power.
Exactly those kinds of things. It's quite remarkable. He's implicitly admitting that even when you're doing rational physics, trying to apply pure concepts to nature, choosing the right way to apply them involves this comparative inductive judgment.
So what were the arguments? Why did he think his force-based MD theory was better?
Well, first he argued it was simpler and more homogeneous. It explained everything using just fundamental forces and their laws, fewer basic ingredients. This ties directly back to that regulative principle of homogeneity we just talked about, Occam's razor, basically.
Okay, simplicity. What else?
A huge point for Kant was empty space. Atomism requires empty space for the atoms to move in, but Kant thought empty space was a massive theoretical problem.
Why? Because you can't perceive it.
Precisely. It has no empirical content. You can't experience nothing. So for Kant, empty space is this purely conceptual thing, a metaphysical posit that falls outside the bounds of possible experience, and therefore outside justified knowledge according to his own critical principles. His dynamical theory, based on fields of force filling all space, avoided this problem.
So his theory was simpler, and it fit better with his own epistemology. Doesn't require believing in something unexperienceable.
That's the core of his argument for MD. No, he was fair. He admitted atomism had advantages too.
Like what?
He said it was most tractable to mathematics. It's easier to calculate collisions and trajectories if you think of things as little solid balls. He also conceded that atomism seemed, maybe, a bit better at explaining the sheer variety of different kinds of matter we see.
So atomism was maybe more practical for calculations, but his dynamical theory was metaphysically cleaner, more unified.
That's the trade-off he saw. And ultimately, Kant argues his dynamical theory, MD, is the winner. Why? Because its advantages, simplicity, homogeneity, avoiding empty space, outweighed the mathematical convenience of atomism, especially when aiming for deep, fundamental explanations.
This whole comparison, listing pros and cons, weighing theoretical virtues, that sounds exactly like IBE, choosing the theory that provides the best overall explanation.
It's undeniable. He's making a judgment based on explanatory power, coherence, and theoretical economy. It shows IBE wasn't just some vague intuition for him. It was a structured method he used to justify his own physics, grounding certainty in comparative explanatory virtue, not just pure deduction.
The implications are pretty big. If Kant needed IBE for his physics, maybe induction is just fundamental to how we build metaphysical pictures of the world.
I think that's exactly the conclusion inductive metaphysics draws from this, and it goes even further, right to the edge of reason.
What do you mean?
This brings us to case 4, doctrinal belief, the transcendent use of IBE.
Transcendent use. So going beyond possible experience now.
Yes. Remember those regulative principles pushing us towards systematic unity? Reason doesn't just start at the boundaries of experience. It keeps seeking the unconditioned, the ultimate explanation for everything.
And this leads to?
This leads to what Kant calls doctrinal belief, the prime example being belief in God.
Okay, how does IBE get us to belief in God in Kant's system? I thought he criticized the traditional proofs.
He did criticize them as sources of objective knowledge, but he repurposes the underlying logic, especially of the physico-theological proof, the argument from design, as a form of IBE justifying belief.
How does that work?
It goes like this. First, reason, guided by its regulative principles, demands ultimate systematic unity in nature. Second, we look at the world, and inductively it does seem remarkably ordered, interconnected, almost purposeful. Third, the best explanation for this observed or inferred systematic unity and purposiveness is the idea of an intelligent designer, or God.
So God is the best explanation for the order we see, which reason demands we find.
That's the structure of the argument. It's an IBE where God serves as the unconditioned ground for the conditioned unity of the empirical world.
But did you say Kant didn't think this was knowledge?
Absolutely crucial distinction. He calls it doctrinal belief. He thinks it's subjectively justified. It provides a necessary completion to reason's systematic project. He even calls it firm confidence, something much stronger than just a guess or opinion.
So it's a belief we're justified in holding, maybe even need to hold for reason to be satisfied, but we can't prove it objectively.
Exactly, because God, as the unconditioned, lies outside the realm of possible experience. We can never have objective theoretical knowledge of God. The belief remains subjectively necessary for reason's coherence, but lacks objective validation. It's the best explanation for reason's demands, but not demonstrable knowledge.
Wow. So IBE, for Kant, stretches all the way from choosing between physical theories to justifying belief in God. It's not just a scientific tool. It's fundamental to how reason itself tries to make sense of everything, even beyond proof.
That's the argument. It shows the incredible reach and power Kant attributed to this inductive explanatory mode of reasoning, even as he carefully marked its limits.
Okay, this deep dive into Kant is really shifting my perspective. If his system, which I always thought of as the peak of a priori reasoning, actually relies so heavily on inductive methods like the analytic method, regulative principles, and especially IBE, well then inductive metaphysics isn't some weird outlier. It's carrying on a core philosophical tradition.
That's exactly the view contemporary IM proponents take. They see themselves as continuing this project of integrating empirical methods with metaphysical inquiry.
So what happens when we take this inductive toolkit and apply it to philosophical problems today in the 21st century?
Well, the method of abduction, or IBE, remains absolutely central. It's seen as the primary engine for gaining any new, non-deductive knowledge about the world, whether in science or metaphysics.
And contemporary philosophers are really digging into how reliable it is, right?
Oh, definitely. There's a lot of discussion about the indefeasibility of abduction. This is the argument that basically you have to use abduction if you want explanatory knowledge. There's just no other logical way to get from observed data to hypotheses about unobserved causes or structures. Deduction can't do it. Simple enumerative induction can't really do it effectively either.
So IBE is kind of the only game in town for generating new explanations.
That's the claim. And this leads people to try and formalize it, which gets into logical abductivism. Can we actually pin down the logical rules that make one explanation objectively better than another?
Like codifying virtues, simplicity, scope, coherence, fitting the evidence.
Exactly. Trying to make IBE less of an intuitive art and more of a rigorous defensible method. It's a huge ongoing project.
And where is this method being applied? You mentioned philosophy of mind earlier.
Yeah, philosophy of mind is a great example. Think about it. How do we justify believing other people have minds, or that specific brain activity is or causes conscious experience? We can't directly observe consciousness in others.
All right, we infer it from behavior, brain scans, things like that.
Precisely. Those are abductive inferences. We say the best explanation for this complex behavior, these neurological patterns, this verbal report, is that there is an underlying conscious state or process. And the big metaphysical debates, materialism versus dualism versus functionalism, are essentially large-scale IBEs. Each theory claims to be the best overall explanation for all the mental and physical data we have.
Okay, that makes sense. But IM isn't just applying IBE, is it? You mentioned refining concepts.
Right. It also uses inductive insights, often drawn from scientific practice, to sharpen the very tools of metaphysics. Take the concept of ground.
Ground. That's about fundamental dependence, right?
Yeah.
Like properties depend on substances or mental states depend on brain states. Not necessarily causal dependence, but deeper.
Exactly. Metaphysical dependence or priority. Traditionally, philosophers often treat ground as this purely abstract, logical relation. But inductive metaphysicians look at successful science and ask, how do our best theories actually structure dependencies? What counts as fundamental in physics or biology?
So they want to make the philosophical concept of ground more like the explanatory dependencies we find in science.
Yeah, they engage in conceptual reengineering. They try to refine the notion of ground so it better reflects the hierarchical, explanatory structures that actually work in scientific practice, make it less of an armchair concept and more empirically informed.
And this approach must challenge skepticism about metaphysics itself.
Directly. It tackles skepticism about metaphysical explanation. Skeptics often say metaphysical explanations are unverifiable, just speculation. IM counters by saying, hold on. The criteria we use to judge a good metaphysical explanation, simplicity, unity, coherence, explanatory power, are the same criteria we inductively derive from what makes a good scientific explanation.
So if you trust science, which relies on IBE for its unobservables, like electrons or fields, you should also trust metaphysics when it uses the same IBE reasoning for its unobservables, like grounding relations or fundamental properties.
That's the core argument. The justification is parallel. It aims to put metaphysical explanation on a methodologically similar footing to scientific explanation.
This seems particularly relevant now with big data and complex modeling. You mentioned the link between data, curve fitting, and model building.
Yes, this is a huge area. We can build incredibly complex models that fit data points perfectly, make accurate predictions, curve fitting, machine learning, etc. But when does a model that works transition from being just a useful predictive tool to reflecting the actual causal structure or laws of the reality it's modeling?
The correlation versus causation problem, but on a metaphysical level.
Exactly. That leap from this model predicts successfully to this model reveals the underlying metaphysical reality, the laws, the causes, is a massive inductive inference. And IBE, the claim is often a Lufton. The best explanation for why this model is so predictively successful is that it has latched onto something real about the system's structure or dynamics. IM tries to provide the philosophical framework for understanding when that inference is justified.
This all sounds like it feeds back into how we even form our concepts. You mentioned conceptual reengineering again, and naturalness.
Right. It connects to discussions about how we learn and refine concepts. Some concepts seem more natural than others. They seem to carve reality closer to its actual joints. Think electron versus some gerrymandered category.
And natural concepts are better for.
They are better for making successful inductive inferences. They support better predictions, lead to more fruitful theories. There seems to be a link between naturalness and concept learning. IM suggests we should pay attention to which concepts prove most inductively powerful in science and use that as a guide to refine our metaphysical concepts too. We want our philosophical toolkit to contain concepts that actually help us track the structure of reality, not just inherited notions. And this naturally leads us to ask, okay, if IM has these tools and this approach, how does it actually help us understand specific scientific domains? How does it guide our thinking when we get into the nitty-gritty of physics or biology?
Right, moving from the general method to concrete applications.
Yeah.
Where does IM make a difference in, say, philosophy of physics?
Physics is often seen as the most fundamental science, so it's a key test case. One major area is understanding the role of simplicity. We talked about Kant using it, but physicists constantly appeal to simplicity, elegance, or beauty when choosing between theories. Think string theory versus loop quantum gravity, or interpretations of quantum mechanics.
But is simplicity just nice to have? Or does it tell us something real about the universe?
That's the IM question. Is simplicity just a pragmatic or aesthetic preference for scientists? Or does the historical inductive evidence, the fact that simpler theories have often turned out to be more successful, more predictively powerful, suggest that the universe itself might have a bias towards simplicity?
So IM would argue that the success of simplicity as a methodological guide gives us inductive reason to believe simplicity is a metaphysical feature of reality.
That's a strong current within IM. It takes the success of the method as evidence about the world the method investigates. It's a meta-inductive argument.
Okay, what about specific problems in physics? Like time.
Time. Definitely one of the biggest headaches. IM methodology is crucial for tackling the problem of the direction of time.
Right, the basic laws of physics mostly don't care if time runs forwards or backwards.
Exactly. They're time-symmetric mostly. Newton's laws, electromagnetism, relativity, even basic quantum mechanics. Run the equations backwards, they still work.
But the world we experience absolutely has a direction. Eggs break, they don't unbreak. We remember the past, not the future. Entropy increases. The arrow of time.
Precisely.
Yeah.
So why the mismatch? Why fundamental symmetry but macroscopic asymmetry? Any proposed solution, and maybe it's about the low entropy beginning of the universe, maybe it's statistical mechanics, maybe it requires new physics, is going to be an inference to the best explanation.
You mean we have the observation, time's arrow, and we need to infer the underlying metaphysical reality that best explains it.
Yes. Which metaphysical picture of time? Is it a block universe where all times exist equally? A growing block where the present moves into the future? Something else entirely? Provides the most coherent and powerful explanation for both the fundamental laws and the observed asymmetry. IM provides the framework. Evaluate the competing metaphysical hypotheses based on their explanatory power regarding the temporal features of our universe. We have to infer the nature of time that best explains the evidence.
Okay, that makes sense. What about biology? Philosophy of the life sciences seems like a very different beast from physics. So much complexity, contingency.
Absolutely. Biology presents unique metaphysical challenges precisely because of that complexity, emergence, and historical contingency. Pure reduction often fails here.
So where does IM come in?
One key area is understanding potentialities. Think about the potential of a seed to become a tree, or a stem cell to differentiate into various cell types. These are fundamental biological concepts, but what is a potentiality metaphysically?
It's not just a possible future, right? It seems like a present property of the seed or the cell.
Exactly. IM pushes us to define the causal basis of potentialities. What is it right now in the physical structure and context of the seed or cell that constitutes this potential? It's not just it might become X, it has the current capacity to become X under certain conditions.
And defining that capacity must be complicated in biology.
Hugely complicated. IM highlights several factors we have to consider, drawing inductive lessons from how biologists actually study these things. We need to account for extrinsicality. The potential often depends heavily on the environment. The seed needs soil, water, light.
Right, it's not just internal.
Then there's multi-levelness. The potential might involve interactions across scales, from genes to proteins to cellular structures to tissue interactions. It's not located at just one level.
Right.
And finally, processuality. Biological capacities are often dynamic, they unfold over time, they are processes, not just static states. So IM uses these inductively gathered insights about biological reality to build a richer, more adequate metaphysical account of what a potentiality is, grounding it in the messy details of life sciences.
So it stops potential being some vague philosophical notion and tries to define it based on how it actually works in biology.
That's the goal. And another big area is the metaphysics of evolution. IM helps refine core concepts there, too, like fitness.
Fitness, survival of the fittest. But defining fitness can be tricky, right? Is it just who survived? That sounds circular.
It can be. If fitness is just defined retrospectively who did survive and reproduce, it doesn't have much predictive power. IM supports refining fitness into a propensity concept.
Fitness is a propensity, like a tendency or disposition.
Yes. Thinking of fitness as a probabilistic propensity, a causal tendency of an organism with certain traits to survive and reproduce in a specific environment, it's grounded in the organism's actual physical makeup and its interaction with its surroundings.
And why is this an IM move?
Because the justification for adopting this propensity view is, again, an IBE. The argument is, The best explanation for the predictive success of sophisticated evolutionary models is that they are tracking real propensities in the organisms and environments, not just summarizing past outcomes. The move from predictive utility to asserting a real underlying causal propensity, that's inductive metaphysics at work, refining a scientific concept to give it more causal and explanatory depth.
So it seems like whether we're looking at Kant wrestling with atomism in the 1780s, or modern physicists debating the arrow of time, or biologists defining fitness, the underlying logic keeps coming back.
It really does. Observe the world, look at our successful ways of understanding it, and infer the underlying structures of the metaphysics that make the best sense of it all. In a deep way, inductive metaphysics argues the scientific method is the metaphysical method. #tag outro.
Well, we started this deep dive questioning that old picture of metaphysics as purely deductive armchair reasoning. And what we found, tracing this idea of inductive metaphysics, is that it acts as this vital bridge. It connects Kant's rigorous attempt to ground knowledge a priori with the messy, data-driven, model-building world of contemporary science. It suggests that the search for scientific understanding and the search for fundamental reality aren't separate projects. They're intrinsically linked.
I think that's exactly right. And the core lesson, especially seeing how central IBE was even for Kant, is that this inference to the best explanation is incredibly powerful. It's not just a little tool for deciding between two scientific theories like Kant picking dynamism over atomism because it seemed simpler and avoided empty space.
Right, it's bigger than that.
It's a fundamental meta-theoretical tool. It seems essential for building the coherent, systematic frameworks that knowledge itself seems to require. It's what drives that demand for unity that Kant saw in reason.
And that drive for unity, powered by IBE, took Kant all the way to justifying doctrinal belief that firm confidence in things like God, based on them being the best explanation for the world's order, even without objective proof.
Yes, which leaves us with a really provocative thought, doesn't it?
It does. If IBE, this core method drawn from successful science, can lead us to strong, subjectively justified beliefs that go beyond what we can strictly prove, then you have to ask yourself,
where exactly is the line? What's the real difference between a theory being the best explanation of the available evidence, based on rational criteria like simplicity and coherence, and it being merely the most compelling explanation for our human reason, the one that best satisfies our deep-seated need for order, unity, and maybe even purpose?
is there a clear line? And thinking about your own life, when you try to make sense of the world, if the method of science, IBE, points towards a belief that feels right, that provides that systematic coherence but can't be objectively proven, is that enough? How much weight should we give to the explanation that simply makes the most sense to us?
A challenging question about the limits and power of explanation itself, something to definitely mull over.
Thank you for digging deep with us today.
Well, my pleasure.
We'll see you next time on The Deep Dive.